All right, guys, so to continue on, we've got our quadrilateral properties, 4 sides, 360. Those properties flow down into what's called a parallelogram. And remember, those have 6 properties of their own that they bring to the table in addition to all quadrilateral properties. So they also get the properties here flowing down. Now, the properties of parallelogram split into rhombus and rectangle. What that means is properties flow down, but they do not flow side to side, which means the rhombus is going to inherit the quadrilateral properties and the parallelogram properties. The rectangle will also inherit quadrilateral and parallelogram. However, they will each have independent properties of their own that do not share across. So rhombus will have 3 and rectangle will have 2. Now notice how square is at the bottom and it has no pictures next to it. What that means is the square basically sits at the bottom of the chart and inherits all of the properties, basically making the square the most selfish shape that there is, because it just takes all these properties and it gives nothing in return. Like, there's nothing special about a square. All the things that we know about squares are actually other shape properties. So what we're going to do is I'm going to kind of scroll into just rhombus so we can kind of focus on the rhombus properties. Now, the rhombus, since it's below quadrilateral and parallelogram, okay, since it's below, it's going to inherit all quadrilateral properties, and it's going to inherit all parallelogram properties. Now, there is a symbol for parallelogram. I will put it in parentheses. It basically looks like a miniature parallelogram. Now, it's not going, the rhombus will not have its own property, okay, or its own symbol. It's not going to have its special little symbol just for it. There's the parallelogram symbol, and that's basically it. Okay. So it inherited those, which means all of the properties up above are also rhombus properties. However, there are 3 properties that are special to just rhombus. Those properties are all sides are congruent. Now, just like in a parallelogram, the opposite sides are parallel and the opposite sides are congruent. So just like that first property that or the second property that we learned, where the opposite sides are congruent, as you move down, rhombus makes that more specific. So the opposite sides, top and bottom, here and here. So instead of them all being opposite sides being equal, all of the sides are the same. Okay? So it kind of takes that property and just makes it a little bit more specific. All right, the next property, okay, is that the, the diagonals bisect each other. Or, excuse me, not bisect, I'm sorry. Diagonals are perpendicular. Remember, the symbol for perpendicular is that upside down capital T. What that means is AC and DB create 4 90-degree angles. They're perpendicular to each other. So what's going to end up happening is you're going to have triangles that are right inside of a rhombus. And the last one, diagonals bisect the vertex angles. What that means is, let's kind of flash back up to here, zoom everything in. There we go, perfect. Remember, in a parallelogram, alternate interior angles existed. Okay, so let's take this blue one. This angle will still be congruent to this one. However, the different colored dots mean different angle measures. So the diagonals bisecting angle A means that this angle and this angle will also be the same. So instead of them being 2 different colors, you're going to have 4 that are the same and 2 are the same. So this one will be here, but this one will also go here. So you actually end up having 4 congruent right triangles. excuse me. Thank you. So it kind of combines these together. It takes the parallelogram property of alternate interior angles being congruent, but it makes it more specific, okay? Since you've got congruent sides, you're going to have more congruency within your rhombus. So these rhombus properties, again, are special to just the rhombus. No other shape really has them except the square, because the square is at the bottom of that chart. Let's see here. I'm trying to find my blue highlighter. I know it's weirdly specific, isn't it? Let's see. Well, hold on. I know it's really weird to need a specific color, but if I don't match my colors for my old notes, it's going to throw me off. All right, so these rhombus properties, sorry about that. These rhombus properties right here so the rhombus, what it does is it inherits these three properties from no one. Like, these are its own unique properties. So these properties are uniquely the rhombus. Okay? So let's go on over to rectangle. Now, the rectangle is also below, sorry, I can't really turn my paper anymore. There we go. The rhombus, or the rectangle, is also below quadrilateral and parallelogram. So it gets all quadrilateral properties and all parallelogram properties. And I'm going to use the symbol for parallelogram because we just learned it. The more you use the symbols, the easier this is. So quadrilateral properties, meaning all rectangles will have four sides. Okay, makes sense. We all know what rectangles look like. We also get all the parallelogram properties, meaning our parallel sides, opposite sides are equal, all of that stuff. However, the rectangle brings two properties that are uniquely its own. First is that all vertex angles are 90 degrees, which means angle A, B, C, and D are all 90. Now, we usually equate that to square, but remember, square steals all of its properties from other shapes. So that's actually a rectangle property. The last one is that the diagonals are congruent, or bisect each other and are congruent. So they bisect each other, which is a parallelogram property, and are congruent, which means DB and AC are equal, but also all of these are equal. So segment AB or AC is congruent to segment DB. Now, it's very similar to this property. The diagonals bisect each other, but what makes them different is since these angles are all 90, the diagonals, actually all of these little pieces, end up being the same. Now, those properties are special just for rectangle. So rectangle did not steal those two unique properties from any shape. Those are uniquely the rectangle. So the rectangle, good old rectangle, he's got two properties to share. And the thing is about sharing, okay, sharing isn't really caring in this flowchart because the square is just kind of like that person in your group project that doesn't do anything and just gets to absorb all of the properties, which is exactly what good old square does. So square is at the bottom of the flowchart. Square is a super selfish shape, okay? It just wants to take properties from literally every other shape that there is. Like, it just steals everything. So notice this flow chart. And if you want a better picture of the flow chart as a whole, you can go ahead and turn to page 22. I think I have 22 over here. Let me see. I do. So eventually, right now, we're on this section. Today, we're going to be doing parallelograms and trapezoids, and then we'll move on to kites. So we will talk about this flow chart, but as a whole, right now, we're just focusing on this page, which looks like this. So notice how square is at the bottom. That means the square just sucks up everybody else's properties because it's a jerk. Okay, it just absorbs everything. It gives nothing in return. It's a very selfish shape. It has nothing that's unique about it. So this square, since it's at the bottom, all of these properties, the square automatically gets. So the square automatically gets, let's see here, all quadrilateral properties. Okay, it's going to get all parallelogram properties. And I'm going to move those dots over here because I don't want to put them over here because I think it's going to look a little bit weird. So I'm just kind of editing as I go. It gets all quadrilateral properties. It's going to get all rhombus properties. And it also gets all rectangle properties. Like, literally, the square gives nothing. It takes everything. It gets every single property of all of the shapes below it, okay? So anytime you are dealing with a square, it automatically gets every single property that's previously discussed. Its angles are all 90. It's got congruent sides. So the property that you thought this whole time of, oh, sides have all congruent sides. That's not a square property. It inherited that idea from the rhombus. So everything you know about a square is actually from a bunch of other shapes because the square doesn't have any special properties of its own. It just steals them all. So one thing I want to make sure that we know before we continue on to just dissecting the flow chart and making everything kind of more visual for you, the properties flow down. So everything kind of trickles down. Everything gets before. So like square, it's going to get quadrilateral, parallelogram, rhombus, rectangle. Some things that you need to know. When you're classifying, you're going to classify up. So a square is also considered a rhombus because it has all of the characteristics a rhombus has. So a square can also be called a rhombus, a rectangle, a parallelogram, and a quadrilateral because that shape is below or up below everything. So when you're talking about properties, the properties trickle down, and then when I'm classifying, you classify backwards. So a rectangle could be considered a parallelogram, and a quadrilateral because those are the shapes that are above it in the flowchart. However, it's very important to remember properties don't flow side to side. So the rhombus and rectangle cannot share any of their unique properties. They can only share down. So on the next page, we're going to make this a little bit more visual and show how it appears on all of our shapes. And then we'll talk about trapezoids.